Hi guys, so today we're going to take you through how to construct the locus of point P, which is also known as the cycloid. Now, I already partially constructed this just to speed up the video a small bit, right? So all we have here is our circle, and it's traveling clockwise in this direction along this flat line here. So what we did to begin was, extend the baseline out from P, and then we divided up our circle into 12 parts, as you can see here, using 30/60 set squares. And then what we did was we took a distance between one of the elements because we want to approximate our circumference. So that's what we did here then. We marked off each little distance on there, and that's approximately the same length as our circumference. So then what we did then was, from the center, we extended another line out, and this is the line that our center of the circle will always be on. So all these points are where our center will be on where we want to see our point P. So we'll have center 1, center 2, center 3, so on and so on. So the first thing we do when we want to find a point on the cycloid is we'll take a point. So say we'll start off at point 1. So if we take distance from P to 1 on the circumference of our circle, put it on where that point 1 would be rolled to, describe an arc, and then if we take the radius of our circle and put it on the center when it's at position 1, and describe another arc. It's probably a bit hard to see, so I'll mark it in red. Where those two arcs cross give us a new point on the cycloid. So this is, so that's point P1 as an example. So I'm going to go through, I'm going to construct another half the cycloid, and then we'll construct the following half then. Right, so now just to show you how to actually construct a point properly, because inside there is a bit congested. Right, okay, our next point is point 7. So if we take our distance on our compass, put our compass on point 1, stretch it to point P, right? So we take that distance, we place it on when 7 is rolled around. So as 7 rolls around, it'll end up where our compass is right now. And if we scribe an arc, scribe that arc, so then we know that as our circle rolls around, we'll have the same constant radius. So if we take this radius here and put it on the center of our circle when we're at position 7, scribe an arc, where those two cross is a point on our cycloid. So this would be P7. As an example. So all we need to do is just, with that principle in mind, just keep applying it, and then it'll gradually give us all the points on our cycloid. So it'll be the same when we take, say, the next one. We'll take our distance from 8 to P, put it on point 8 when it's on the baseline, scribe an arc, take our radius, put it on center at when it's at 8, scribe another arc, and that'll give us another point, and so on and so on. So it's just as long as we keep applying this principle, we'll get our cycloid. Right, so really quickly, now that we have our fully constructed cycloid, I want to show you how it works through the principle of triangulation. So say we have a green triangle here between P8 and our center. So let's see what happens, right? So this is our point 8 here. So if I join, or P8, should I say? So if I join this point back to 8, and then P back to here, and our center back to 8. What we can see is that our triangle has almost undergone axial symmetry, and that our triangle has simply just rotated around. So this is how our principle of triangulation works. That's how to construct a cycloid, guys. Thanks.